Hi, this is Bronya. Welcome back to webinar. Last time we talked about introduction to JavaScript, we talked about variables, we talked about types, we talked about the fact that programming is pretty much just moving values around. And there are inputs and we need to present some output from our program. When we're talking about types, we end up with something strange. So let's start running through these instructions. So let's start with 3 plus 2. Well, that's 5. That sounds correct. 3 bigger than 2. Well, that's true. As well, sounds correct. And you can, by the way, see that based on the operator, we get different types. In this case, we get number. In this case, we get Boolean value. And this is what we end up with last time. 3 bigger than 2, then bigger than 1. Well, that's obviously true. So we would say the programming language actually says, well, it's false. Well, this looks like a false. It's actually true. It's weird. So let's apply plus to 2 strings. We got hello world. We actually concatenated, added together those 2 strings. Hello space world. So what happens when we add hello and number 3? Not a string 3, number 3. Well, we got a string that's actually hello 3. That's a string. What happened when we multiply it? Get something strange, none. It's actually not a number. What happens when I try to divide? Well, this is obviously an error. While this could make sense from some perspective, this doesn't make sense at all, yet we got something. This makes no sense. We got infinity. So those 2 applies to math. I'm going to talk about them later on. Let's start with this. JavaScript does something that it's called type coercion. This would, in a lot of languages, a lot of programming languages, simply resulted in error. Because you have string and you have a number. Those are 2 types that have nothing in common. What type coercion does is it tries to figure out what to do with different types of values, different types of data. And this time it tries to figure out, okay, so this is a string, there's a plus, I can add strings, and I can convert this to string as well, string 3, and add it together. It makes sense. Trying to convert this to number makes 0 sense. It doesn't make sense at all. So that's what the JavaScript is trying to do, and that's called type coercion. In this case, well, there's nothing like the multiplication simply says, okay, that's gonna be a number. But JavaScript cannot multiply string by number. It makes no sense. So what we get here is actually a special value none. None is a special number, and it means not a number. It's a special value when you're doing operations that should result in number. There is no other way for the expression to end up, but JavaScript don't know how to make it a number. Interesting thing about number is that unlike other numbers, it cannot be ordered. It belongs nowhere. We know the order of numbers like -4, -3, -2, etc. -1, 0, 1. There is an order to numbers. This number cannot be ordered. So what does it mean? Both of those are false, because none cannot be ordered. And because it cannot be ordered, it cannot be equal. We haven't talked about this operator yet. This operator is comparison. We compare values. We compare values using bigger, lower, or equal. We don't use single equal, because single equals means assignment. We assign 5 to C. So when we compare, we can use this. This is better. Actually, we're gonna talk about it today with the coercion. What the? It's a better comparison. As I said, we're going to talk about it, but it doesn't equal to itself. It's the only primitive type that's not equal to itself. The only primitive value that's not equal to itself. That's obviously true. We're going to talk about comparison. There is a historical reason for it. There wasn't a way for some time to report an error, to manage errors in a code. Now there is a way how you can so-called catch an error. So if something goes wrong in your code, the code is correctly written, but the values makes no sense, or something cannot be done with those values. We now have a way to catch that error and work around it. But for a long time there wasn't a way in JavaScript to do this, so the designer of the JavaScript tried to figure out how to work with it. One of the results is the value none. Well, second result is this, which makes 0 sense. We have to live with it. Infinity is actually number as well, and it's bigger than any other number. Except for itself, of course. There's also minus infinity. If we did something like so that's that infinity is infinity, of course. There's a slight addition to math. The only way how to detect the none value, because obviously how do we detect it? If it's not equal to itself, we cannot test for it. There's a, we can call function We're gonna explain function how they work, but there's actually a function that can tell you, okay, that's none. So if I do this is false, this is how is that true? Oh, that should be false. Oh, this is definitely false. Okay, this is definitely true. Oh yeah, of course it's none because it's not a number as well. It's resulted in string, which is not a number. But if you get a result that's actually none, you get as well true. Oh. And this is a little addition to numbers. I've said some things makes no sense. So how does things like this work actually? The type coercion. As I've said, JavaScript is trying to switch types based on what you're asking to do it. So let's check out this one. Now before I get to this one, you can actually ask JavaScript to switch type for you. And you do it by calling functions. We get to what functions are. And the functions are actually name of the types. So when I try to do, for example, string, that's the name of a type. So I'm switching type from string to string. That's obviously string. But if I try to switch type from number 3 to string 3, you see the result is actually string. It's enclosed by quotes. If number 3 well, that's not a number at all. And that would be, it's a different way to typing number. We'll get to it. So similarly as we type differently strings, there's a different type to write numbers. Okay, that's actually a number on its own. But even this string, computer is capable of converting to number. So there are ways how to convert types. And that's of course Boolean. So Boolean, this is true, this is false. So what happens actually here? Well, what happens is that we try to read it as we read math, but that's not how computer works. So what it does, okay, there are two operands, or two operators. They're equal, associativity is left to right. So 3 bigger than 2 turns out to be this. Is true bigger than 1. Well, this operator works with numbers. So we need to figure out how do we convert Boolean to numbers. False is 0, true is 1. There is no other value for the type Boolean. So now we have this. Is it true? Well, no, that's not true, that's false. So the result of this is actually false. So now you should figure out why this works. 3 smaller than 2 becomes false, smaller than 1. False converted to number 0. 0 is actually smaller than 1, which is the reason why the result of this is what we are working on, is actually true. It's due to how the operator works. From left to right, it doesn't work at everything simultaneously. It has to go step by step. So the first operator evaluates the Boolean, and the second operator works with numbers. It again evaluates the Boolean. The result is going to be Boolean, but it works with numbers. So we get a Boolean here, and it tries to rewrite the Boolean to numbers. Type coercion is, well, I'd call it a mistake in the language. As I said, there's a reason why it happened as it happened. I'd call it a mistake in a language, but it is in the language nonetheless. We usually don't want to work with it. It causes issues. Well, that's 32. Because it can convert both to numbers, but JavaScript doesn't care. JavaScript sees, I have plus, I see a string, so let's convert everything to string. For this to work, everything has to be number. This is 6. There's a left to right associativity. Okay, 5, 6, 6 plus string. There shouldn't be an issue with plus. If all of those were numbers, the result's always the same, regardless of the parentheses. Since parentheses have a biggest precedence, it's the biggest precedence grouping. What it happens is that, okay, there's a 3 plus parenthesis. Okay, I need to work with the parenthesis first. Okay, there's a 2 plus parenthesis. I need to work with the parenthesis first. Okay, this is 1a, so this is a string. Number plus string is against string. Number plus string is against string. This can bite you, actually bite you a lot, because, for example, when people submit something, when they type something on your web page, in some input field, it's string. Even when they type a number, it's actually a string. Let me show you. This isn't the HTML course, but it doesn't matter. Okay, we have 2 inputs here. Okay. actually typed word last time. I remember. This can actually really bite you. How how operator works and type coercion, how it works. Pretty much the only viable type coercion that's sort of nice, it's coercion to Boolean. So how coercion to Boolean works? When we want to test for something, does it exist? So for example, Boolean of true is of course true. Boolean of false is of course false. Boolean of 0 is false. Boolean of anything else, except for none, is true. Boolean of undefined is false. Boolean of null is false. Boolean of no text at all is false. Boolean of some text is true. So this is something usually programmers use to test for existence of data. So is there some text? Well, it either is or isn't. This can bite you, but other than that, this type of coercion works. So this is type coercion, and next time we're gonna check out some control structures in language. Thanks for watching. Broňas out.